Now we are in aim 21. In this aim we are going to learn about factorization. It is a very important topic in the algebra. What is meant by factorization? The process of resolving the given expression into some factors is called the factorization. Here we have three types of factorizations will be. Let us see. Factorization. Factorization means we have to resolve the given expression into some factors. In this, first method is taking out common factor. First type, this is the first type, taking out common factor. First of all, what is a common factor? Common factor means a number or a number letter combination that divides each term of the given expression is called the common factor. A number or a number letter combination which divides each term of the given algebraic expression is called the common factor. And how to taking out a common factor? This is one type of the factorization. Now let us see by taking one example. Here is a question that factorize (3a plus 6ab). How to factorize this algebraic expression here? In this method we are going to taking out a common factor. To get the common factor, first step is to do that is you have to find the HCF of each term. First step is find the HCF of each term. Now let me find the HCF of these two. 3a we can write 3 into a and 6ab we can write 3 into 2 into a into b. Now HCF of these two numbers are already we discussed about HCF in the previous aim. So here 3 and a are the common factors. So 3a is the HCF of these two terms. Now the second step is you have to divide each term with this HCF. After that, the coefficient should be enclosed in the brackets and this HCF you should be written outside of the bracket. Let us see solution of this problem. Now 3a is the common factor, no? Now you have to divide this term and this term with 3a. 3a by 3a will give 1 and this is the coefficient of the first term, and find the coefficient of the second term means you have to divide this 6ab with this HCF of 3a. Here 3 2 times will go and a get cancelled. The coefficient of the second term is 2b and this 2b also you have to write here and you have to enclose them in brackets. And what is the HCF of our expression? That is 3a. The 3a you have to write before the bracket. In this way you can factorize the given algebraic expressions. Now let us go with one more example. That example I am going to take from our material. Factorize (2ab plus 6ad). Now I am going to solve this problem by using this method, that is taking out a common factor. In this method, first of all we have to find the HCF of these two terms. and find the HCF of these two terms. What is the first term? Here it is 2AB. 2AB we can write 2 into A into B, and 6AD we can write 6 we can write 2 into 3, and AD we can write A into D. Now what is the HCF of these two numbers? And here 2 is the common factor and A also the common factor. Overall HCF of these two numbers is 2A. Now divide each and every term in our given expression with this HCF. Now my coefficient is 2AB by 2A. 2A get cancelled. B is the coefficient of the first term. And let me find out the coefficient of the second term too. And the coefficient of the second term is here 6AD by 2A gives here AA get cancelled, 2 will go 3 times, and the coefficient of the second term is 3D. Now it is time to enclose the two terms of the coefficient in brackets. Now write B plus 3D in the brackets, and it is time to write the HCF before the bracket, which is 2A, and this is the answer for the given expression. In this way we can find the factorization. Let me go with the second method. The second method is grouping. And the type 2 is grouping. How to factorize the algebraic expressions by using this method? And let me take one more problem from our textbook for easy understanding. Now I am going to take the problem is AX minus BY factorize AX minus BY minus AY plus BX. Now how to factorize this problem in this method? In grouping we have to arrange the given algebraic, we have to arrange the terms in the given algebraic expression into some groups such that each group should contain the common factor. First of all, we have to remember whenever we are going to factorize the given algebraic expression in grouping method, we have to arrange the terms which are in the given algebraic expression into some groups such that that group should contain a common factor. Which means, now I am writing the given problem first, that is AX minus BY minus AY plus BX. And here observe this one, and here AX and here BY. This group does not contain any common factor. That's why I am grouping the terms, and here AX and here AY. In these both terms I have A as a common factor. That's why I am grouping these two terms. So AX minus AY I am writing here, and next minus BY plus BX I am writing here. Now if you observe here, each group, here are two groups and each group contain a common factor. Here this group contain a common factor as A and this group contain a common factor as B. Now the second most thing is I should take out the common factor. Now let me take out this common factor, and here A and here it is B. Now A is the common factor. If I take out this common factor, here it will be only X and here it will only be Y. And now here what is the common factor? B is the common factor plus B, and here minus Y plus X. Minus Y and here plus X, and here A into X minus Y plus B into minus Y plus X we can written as X minus Y also. Here if you observe here, again we have the common factor. Now factorize it, and here is X minus Y and here also X minus Y. it is the common factor. Why? Because both the terms have the same factor. If the both terms have the same factor, I mean that is only the common factor. We can take out this common factor here. That is, if you take out the x minus y and the remaining is here a and here b. In this way, we can factorize the algebraic expression. And the third type is difference of two squares. And the third type is difference of two squares. In this method, now the third type of the factorization is difference of two squares. Difference of two squares. In this method, the expression can be factorized by using the formula a square minus b square, and we know the value of a square minus b square is a plus b into a minus b. Let me take one example, and here I am going to take the example is factorize 4x square minus 9y square. Here my algebraic expression contains two squares. Now 4x square I can represent as, let me note down the question again, and here 4x square we can represent as 2x whole square, and 9y square we can represent as 3y whole square. If you observe this expression, simply it is in the form of a square minus b square. A square minus b square formula is a plus b into a minus b. So let me write this one in the form of a plus b into a minus b. Here a means 2x, b means 3y. So I can write 2x plus 3y into 2x minus 3y. In this way, we can factorize the algebraic expressions which are in the form of difference of two squares. And how to factorize a multinomial? Let us see now. Factorization of multinomial. In this method, if the multinomial can be written into product of two or more algebraic expressions, if you multiply those two or more algebraic expressions, the result will be equal to the given multinomial, then we can say each of the algebraic expression is said to be the factor of this multinomial. In this way, we can factorize the given multinomial. Let me take one example. From our textbook only, I am taking this example too, that is factorize 9x square plus 6xy plus y square. Factorize 9x square plus 6xy plus y square. Now let me take two algebraic expressions which are 3x plus y and 3x plus y. If I multiply those two, I am taking here 3x plus y and 3x plus y. Both are same actually. If I multiply these two algebraic expressions, the product is equal to this multinomial, then I can say these two are the factors of the given multinomial. Let me see whether these two are equal or not. If you see these two algebraic expressions, these are in the form of a plus b whole square formula. Already we learned this type of products in the previous aim, and this we can write 3x plus y whole square, and we know the a plus b whole square formula, which is nothing but a square plus 2ab plus b square. In the place of a it is 3x, in the place of b it is y. Now a square means 3x whole square plus 2ab means 2 into, in the place of a 3x, in the place of b it is y. B square means y square. Now 3x whole square means here 2 belongs to both 3, here 2 belongs to both 3 and x. So we can, 3 square means 9, x square means x square itself. Now multiply the numerical coefficients first. 2 3s are 6, x into y, xy plus y square. If you observe this one, 9x square plus 6xy plus y square is equal to our multinomial. So we can say 3x plus y whole square or 3x plus y into 3x plus y are the factors of the given multinomial. This is called the reverse multiplication. This is called the reverse multiplication of the factorization. So here we have to assume the two algebraic expressions. And now what is a prime multinomial? What is a prime multinomial? A multinomial is said to be prime. The multinomial should contain the factors 1 and itself only. Then only we can say that multinomial is a prime multinomial. Let me take one example. X plus 1 by x. It is a multinomial, right? Yes, it is. And can you factorize it any one of the method? What we discussed previously, taking out a common factor, otherwise in grouping method, otherwise whether is it in difference of two squares? No. Otherwise reverse multiplication? No. So it cannot be factorized. Why? Because it has the factors 1 and itself means that only. So we can say this type of multinomials are called as prime multinomials. And now let me discuss two more subtopics in the factorization. Suppose an algebraic expression contains a monomial as a common factor. How to factorize that? And the second subtopic I am going to tell you is, if an algebraic expression contains binomial as a common factor, how to factorize that algebraic expression? Let us see by taking an examples. Now, I am telling you that how to factorize a algebraic expression which contains a monomial as a factor. Let me take one example. Factorize 6a square plus 3a. If you observe here, we have a monomial as a common factor. What is that monomial? Yes, absolutely right. That is 3a. So 6a square we can write. Let me solve this one. 6a square plus 3a. 6a square we can write 3a into 3a. Sorry, 6a square we can write 3a into 2a plus 3a we can write 3a into 1. If you observe this algebraic expression, here 3a will be a common factor in this algebraic expression, and we know 3a is a monomial. In this type, we can take out this common factor. Now, take out this common factor, and what are the remaining terms in this algebraic expression? So, in the first term we have 2a, and the middle symbol is plus, that's why I am keeping here also plus, and the remaining term in the remaining factor in the second term is 1. So, in this way I can factorize. Suppose, how to factorize an algebraic expression? How to factorize an algebraic expression which contains a binomial as a factor? Let us see with an example. Same thing, how to factorize an algebraic expression which contains binomial as a factor. Let me take one more example from our textbook, that is factorize 2x of x plus y plus 3 of x plus y. Now, let me solve this problem. Now, note down the problem again. 2x of x plus y plus 3 into x plus y. Here, clearly we can say x plus y is the common factor in the both term, in this algebraic expression, because first term contain x plus y and the second term also contain x plus y. Here, x plus y is the common term in this expression. What would you say about the x plus y? Is x plus y a monomial? No, x plus y is a binomial. That's why here binomial is a factor in this algebraic expression. Let me take out that binomial. Now I am writing I am taking out that x plus y, and what is the remaining factor in the first term? That is 2x. What is the remaining factor in the second term except x plus y? Yes, it is 3. Why? Because already x plus y we taken out. So, x plus y and 2x plus 3 are the factors of the given algebraic expression. In this way, we can solve the problems which are given in our aim. Thank you.